Okay, so today we are going to start with velocity of separation and approach. See, so what is this velocity of separation and approach? See, you have two objects. Suppose this is object A and this is object B. So there is certain distance separation between these two objects, right? Let's say this is R. So definition of this would be rate at which the separation between two objects changes. Rate at which separation between both objects changes. Maybe decreasing or increasing. If separation will increase, it will be called velocity of separation. And if separation decreases, it will be called velocity of approach. Pretty much straightforward, right? Now, suppose we have we are just analyzing the motion of B with respect to A. So this is the velocity of B with respect to A. Let's say this is relative velocity. This is the relative velocity. So A is at rest, right? Now you can see that if the position vector, I mean the separation between A and B and the relative velocity, they have some angle, right? Theta. Theta is the angle between line joining objects A and B, and this is the relative velocity. Now, so just like break this velocity, relative velocity into two components. One along the line joining objects, that will be V relative into cos theta, and this and one component will be along the perpendicular to the line joining A and B. So this will be V relative into sin theta. Now you can feel that this component of velocity will have tendency to increase the separation between A and B. This does not have any sense over here because you can feel that this is the rod and this is the velocity. This velocity will try to rotate this rod. This velocity will try to rotate this rod. So going forward, like in future, like we'll definitely define some angular velocity as well. So don't worry right now. But there is no use of this component right now. So right now we will just talk about this velocity. See, this velocity is trying to have tendency. You may have this kind of feelings, like this component will try to increase the separation R, right? Now, if I take another example like this is the object A, and this is the object B, and suppose with respect to A, this B has some relative velocity like this. So this is the velocity of B with respect to A. Let's call this relative velocity. Now, if I see again this velocity, if you break this velocity into two components, one component will always be along the line joining A and B, and other component will be along the perpendicular line joining to the to A and B. So this and this. Suppose if this angle is suppose this angle is theta. Suppose this angle is theta. So this angle will be theta. So again, this will have two components. One will be this V relative cos theta, and this will be V relative sin theta. Now you again even feel that this velocity will have tendency to decrease the separation between A and B. This velocity will have tendency to decrease the separation between A and B, and this will just try to rotate this AB. So any velocity, when velocity will be perpendicular to the line of X, a line of line, any line joining this A and B. So perpendicular velocity will always have tendency to rotate that thing. So in this case, this will be known as velocity of approach. Means with this velocity, B is trying to approach A, and in this case, with this in this case, this velocity is velocity of separation. With this velocity, B is trying to go away, go far from A. So this is the velocity of separation. Understood? So this is the concept, right? Now we'll use this. Note it down. And videos, guys. Noted, guys. China and Ayushi. Shagnik, your video. Abro, your video.
Yes, certain.
Okay, now let's take one simple example. Suppose this is x-axis, this is y-axis, this is origin. Suppose there is a rod that is kept like this. This end of rod has some velocity, let's say 3 meter per second, and this end has some velocity like 4 meter per second. Right? Initially at t equal to 0. Now find velocity of separation. Let's say this point is B between point A and B at t equal to 0. See, I'll solve, don't worry. We know that velocity, see, you can, no, it's not like, this is not a rod. No, this is not a rod, but you can, like, these are two cars. You can assume that these are two cars. A and B are two cars. One car is going along x-axis and other car is going along y-axis. So this is the distance. I mean, even this is the separation between these two cars. Car B and car A. Now you can feel that car A is going towards right, car B is also going up. So, like after some time, car A will come over here, car B will come over here. So this distance will increase. So this, if R is the separation between A and B, so it will keep on increasing. So we can say that this is the there should be some rate at which this separation is increasing. So in this case, we can define velocity of separation, not velocity of approach. Then how would you define the velocity of separation? You just have to remember, you just have to break the velocity into two components. One will be line joining the object, and other will be perpendicular to the line. So see, this is the line joining these two cars. So just you just have to break this velocity into two components. One will be perpendicular to this line, and other in the direction of this line. So and here also perpendicular to this line, and then in the direction of this line. Now you do not have angle. No, you have. See, suppose initially this is 4 and this is 3. Just assume that this distance is given. So this angle you can find. This is 37 degree and this is 53 degree. So this is also 37. So this velocity has two components, 3 cos 37 and this is 3 sine 37. And if this is 53, this is also 53. So again, this velocity 4 meter per second has two components, 4 cos 53 and 4 sine 53. So the component which is perpendicular to the line joining car A and B has no significance over here. And we can see that this point B is trying to go away with this velocity. And A is trying to go away with this velocity. So the velocity of separation will be velocity of separation will be 4 cos 53 and plus 3 cos 37. Understood? Suppose if this case was suppose if I consider different case like this. This is this like in this question only. This end is going, car A is going in this direction and car B is coming down. So this car will have two components, one perpendicular to this line and other along this line. And this will have two components, perpendicular to this and along the line. Now you can see that with this velocity A is trying to go away and with this velocity B is trying to come closer. So velocity, if you want to define velocity of separation, so you will say that this velocity, suppose V1 minus this velocity, let's say V2. Because with V1 it is going away and with V2 it is coming closer. So velocity of separation should be V1 minus V2. Note it down. Sriyadi, you're late. You're 14 minutes late. You missed one part. You see, you are not audible. That's why I'm telling you in every video, so that I can, at least understand what if you ask anything. You have question that how did I take this angle? See, in any right angle triangle, I already told you that this is 3, this is 4, and this is 5. So this angle will be 37, and this angle will be 53, and this is 90 degree. This is not the standard angle in mathematics, but in physics we have to remember this. Noted, guys? Everyone noted? Okay, let's go ahead. Now, condition of collision. Condition of collision. Suppose you have two objects or two balls or two cars, anything car A or object A and object B. This is going with some velocity v1 at some angle alpha, and this is going with some velocity v2 at some angle beta. Now you have to find the condition when A and B will collide. See, A will follow this path, any path, right? B will also follow some path. So what is the condition that A and B can collide? It is not necessary that A and B will collide, but under what condition they can collide? So again, what we will do, we will just analyze the motion of one object in the frame of other object, right? So just analyze the motion of suppose B in the frame of A. So now, if you want to go in the frame of A, you have to pay some cost. For that, you have to bring A to rest. So now A will come at rest. A will come at rest. Now you know that because A has come to rest, so you just have to reverse the velocity of A and add it to B. So B has this velocity V2 at some angle beta, and you just have to reverse this velocity. So if you reverse it, this will be like, so just bring it parallel to this and add it over here. So this will be the velocity of A. That is how we analyze the we do the relative motion, right? At some angle alpha. Now break into component. So this will have vertical component, that is V2 sine beta and V2 cos beta, and this will have this V1 will have again two components, V1 sine alpha and one more V1 cos alpha. Now you can think that A is at rest. So if B has to collide with A, B has to travel along this line, AB. Right? Suppose if this component V2 sine beta is larger than V1 sine alpha. So in that case, this resultant velocity would be like this. V2 cos beta plus V1 cos alpha and some angle, some velocity in vertical direction. So resultant velocity will be in this direction. So in that way, in that case, B cannot collide with A and B will go like this. But if this component is more than this, so resultant velocity will be downward, and we have this component. So the resultant velocity would be like this. So again, B will go like this and cannot collide with A. So just to collide with A, B has to go along AB1. For that, this vertical component has to nullify each other. Means this is the condition of collision. V2 sine beta equal to V1 sine alpha. This is the condition of collision. Condition of collision. Don't try to remember this. Just try to understand the mechanism, right? And now, if I ask you how much time it will take to collide, so just B has to travel this distance. Suppose this is L. So the time taken to collide is distance upon this velocity. V1 cos alpha plus V2 cos beta. We have this kind of such kind of problem in aerodome as well. Noted, everyone? Now, next concept will be, and I think this is the last concept. After that, we will take question. Minimum separation. Suppose here is the one object A, and suppose this is the object B. And now I am analyzing the motion of B in the frame of A. So A will be at rest. And B is traveling with some velocity, suppose V relative. So that is velocity of B with respect to A. Now you can see that. Again, if you break this into two components, suppose this angle is theta. Suppose this angle is theta. So if you break this into two components like this and this. So this is V relative sine theta and V relative cos theta. So this velocity, this component does not have any significance over here, and this has some significance. Now, with this is the velocity of approach. So with this velocity, B is trying to approach A. Suppose B is like traveling on this path. Suppose B is traveling on this path. Now you can see that if you take point, suppose after some time B will come over here. After some point, B will come over here. Yeah. Now, if when B will come over here, so B again direction of velocity of B will be this, and suppose join this point. Suppose at this point, this is the direction of velocity of B, and just join this. Now at this, I mean, assume that there will be some angle alpha or theta angle, maybe anything. So this is also alpha. So this is V related. If you break into component here, now you'll find that. Oh, wait. Diagram is not. Diagram is not correct. Wait. This is A. This is B. Suppose B is traveling on this path. Suppose traveling on this path, and B has some velocity V relative. So means in the frame of A, and this angle is theta. So at this point, B will have two components. This velocity will have two components: V relative cos theta and V relative sin theta. Now you can see that B is trying to approach A. So this is called the velocity of approach. This B will come after some time. This B will come over here. Suppose. So again, this is the direction of velocity of B. Join this. Suppose this angle is alpha or any angle. Again, break this into two components. This angle is again alpha. So this is V relative cos alpha, and this is V relative sin alpha. Now you can see that at this point, this is called velocity of separation. This is called velocity of separation because with this velocity, B is trying to go far from A. But here it was velocity of approach. Here at this point, it was initially velocity of approach, but at this point, this is velocity of separation. So initially it might have tried to come as closer as possible to A, and then after that, it has started going away from A. So suppose this distance is decreasing, might have come closer to A, and then after that the separation between A and B might have must have started increasing. So we can feel that this should be the minimum separation between A and B. So as soon as you cross B, now this velocity of approach will convert into velocity of separation, right? So till here, B has tried to come closer to A, and after B will try to go away from A. So this is called minimum separation. So you can feel that at a minimum separation, there won't be any velocity of separation and velocity of approach. Because if like even at this place, if B will have some velocity of approach or separation, so then B might have gone closer to A or away from A, right? So at velocity of minimum separation, there won't be any velocity of separation or velocity of approach. So velocity of separation and velocity of approach has to be zero at the minimum separation. So let's see, whenever we'll solve this kind of question, we'll always try to analyze the motion of one object in the frame of other object, and then we'll solve this. So this is the concept of minimum separation. Now I'll take one question. Note it down if you wish. Noted, everyone? Now I am taking one question. I'll give you 2 minutes to think and then I'll solve. Question is, this is these are two paths perpendicular to each other. One car is over here. One car is over here, moving with some velocity, some constant velocity, 10 meter per second. And other car is over here, suppose B. It is also moving with velocity 10 meter per second. And this initial separation between them is 200 meter. Now I have to find time when separation between two cars will be minimum, and also find minimum separation. Let's try to solve this.
सर ये जो क्वेश्चन है वो पुलिस जीप वाले क्वेश्चन के जैसा है क्या?
हाँ, कह सकते हो।
सर वो आपने वेक्टर्स में करवाया था।
हाँ, तो वो तो बहुत पहले करवाया था, उसको छोड़ो। अभी ये जो कॉन्सेप्ट मैंने सिखाया है ना, रिलेटिव मोशन का, वो अप्लाई करो। सुबह जो हम लोग एनएलएम का क्वेश्चन कर रहे थे, अरे कोई सॉल्व कर दो या उसको, मतलब कोई सॉल्व करो उसको, बहुत लेंदी है। रश्मि करेगी, रश्मि या पार्थ, कोई नहीं करेगा।
सर मैंने ट्राई किया,
नहीं हुआ।
वापस ट्राई करती हूँ।
बहुत
नहीं हो
लेंदी
रहा।
है ना, मन नहीं कर रहा था सॉल्व करने की, इसलिए मैंने भी छोड़ दिया उसको। ठीक है चलो, इसको पहले सॉल्व करो तुम। चलो let me solve now. Okay, see, I'll solve it by into different methods. Method one, very simple method. Suppose question asks, like asking that what is the time of minimum separation. Suppose t is the time of minimum separation. After t time, they will have minimum separation. So in that t time, this a will travel some distance, and that is 10 into t, v into t. B will also travel. See, first understand. After that, you can write. And B will also travel some distance, that is 10t. So what would be this distance? This is 200 minus 10t. So this is the minimum separation. Let's say x is the minimum separation. Now you can use Pythagoras theorem. X squared can be written as 200 minus 10 whole square plus 10t whole square. If x is the minimum, then x square will also be minimum. Now what you do, you just have to differentiate this. So this is 2 into 200 minus 10t into chain rule minus 10. And here 2 into 10t, and then coefficient of t is 10. So 10 will come. And after differentiating it, you can equate it to 0. Now 2 and 2 gone, 10 and 10 gone. Minus will be here. So minus 200 plus 20, and this 10t equal to 0. So 20t equal to 200. So now we can see that t equal to 10 seconds. So after 10 seconds, they will have minimum separation. And to find the minimum separation, you just have to put this t equal to 10 in this equation. And you will find x minimum. Understood? But this is mathematics actually. But we are not sitting in mathematics class. This is physics class. So we need to understand physics, right? First you note it down, then I'll tell you method 2, that is physics. So everyone understand this concept because like after this question, I'll give you tough question that you have to solve. Sorry. Parth, you can see my English.
Yeah, no, it's great.
And credit goes to China. When Parth came back from Dubai, he was like not comfortable with Hindi. I made him comfortable in Hindi. I started speaking English. China, this is because of you only.
Sorry, sir.
Hey, no, it's all right. ये तुमसे क्वेश्चन हुआ था या फिर नहीं हुआ?
मुझे पूछ रहे हो?
हाँ,
हाँ, इसका मिनिमम सेपरेशन 100√2 और टाइम 10 सेकंड्स।
आ गया था तुमसे?
हाँ।
गुड, ठीक है. Okay, now let me solve in physics way. Method 2.
सर ये डिफरेंशिएशन करके हमने जीरो पे क्विट क्यों करा?
ये तुमको तो मैंने फिजिक्स में पढ़ाया था ना, जब बेसिक मैथमेटिक्स पढ़ा रहा था फिजिक्स में, तो मैक्सिमा मिनिमा का वैल्यू कैसे निकालते हैं?
अच्छा ठीक है
याद है?
पर मैंने डिफरेंशिएशन नहीं किया।
हाँ, नहीं, वो ठीक है, अभी मैं आता हूँ ना. Now I'll tell you another way that is significant. See, in this case, what we'll do, we'll just analyze the motion of one object with respect to other. So, analyze the motion of any one object, let's say A, in the frame of B. So, we are now in the frame of B. So, B will be at rest. B will be at rest. शागनी है कि नहीं है? और वो भी जिंदा. हाँ, शागनी तेरा वीडियो कहाँ गया?
सर लैपटॉप चार्जिंग में 5 मिनट दे दो.
ठीक है. तो हम क्या करेंगे? सॉरी, हम क्या करेंगे नहीं? What we will do? We will analyze the motion of one object in the frame of another object. So we'll sit in the frame of B. Now, so B will come at rest. If B will come at rest, then what should be the next step? We'll just reverse the direction of velocity of B and add it to A. So B is going up, you just have to reverse it and add it to A. So this is 10 meters per second downward. Now this is gone. Now B is at rest. Now you can see that A has two components, one along X, along Y. Now the resultant velocity will be something like this. Resultant velocity will be something like this. And on this path now A will come with some velocity 10√2. Resultant of this, both components are same. So at angle 45 degree. Now we can see that A will come on this path, come at this point, and minimum separation will be this perpendicular distance from B, because B is not moving. Na? B will be at rest only. So when A will come over here, that perpendicular, then this is your minimum separation R. Correct? So you have to find how much time A will take to come over here, till here. So see, this is 200. Just take cos component or apply the cos 45 is, suppose this is your X. So cos 45 is base upon hypotenuse. So this is 1/√2. So X is 100√2. Simple. So this is 100√2. And from here you can apply sine 45 is R upon 200. So R is again 100√2. This is the minimum separation. And how much time it will take? So just take like, how much time it will take to cover this x distance. So time is x upon velocity, resultant velocity, 10 root 2. So 100 root 2 upon 10 root 2. So 10 seconds. I hope you all have understood. This is physics. So whenever like you are asked to solve collision problem, minimum separation kind of thing, you always have to analyze the motion of one object with respect to other. Noted everyone? Chalo. Second question you have to solve. Again, similar kind of question. Suppose initially car A is traveling with some velocity, suppose 15 meter per second towards this pole. And here car B is initially moving with some 20 meter per second. The separation, initial separation, this is all at time t equal to 0 initially. Initial separation was 400 meter and this is 500 meter. Again, you have to do the same thing. Find time at when minimum, when there is a minimum separation and what is the value of minimum separation. Find time when separation between A and B will be minimum and also minimum separation. First, you tell me minimum time, how much time they will take. And after that, if that would be correct, then I'll tell you. If not, then I'll solve.
sir.
Yes, tell me. Wrong sign.
Okay.
Wrong sign. Anyone? Anyone else? Parth, Devyani, Rashmi, Abro, Shagnik, Shreya.
5 seconds.
How much?
25.
No. It should be 25.6.
Sir, why 25.6?
Right. Anyone else? Abro, Archit? No, no one. Shabash. See, I'll solve now. Ayushi, no luck, nothing. Okay, do one thing. What we have to do? We just have to analyze motion of one object in the frame of other. So let's analyze with respect to B. So B will be at rest. Now you can see if B will be at rest, what you have to do? You just have to reverse the velocity of B and add it to A. So
Sir,
add
आगे
it.
आंसर.
So add it 20 meter per second downward. Now, see, now you have to see, this is the line joining A and B initially. Now we have to actually see the direction of resultant velocity. So this line, you can say that this angle, if this angle is theta, you can say that tan theta was 5/4, right? Now you have to find the, see, this is 15 meter per second and this is 20 meter per second. So resultant would be how much? 25 meter per second. And you have to find the angle with horizontal. How much angle it will make? It is not going to be same to theta. So tan alpha is equal to 20 upon 15. So 4/3. Now this value is bigger than this value. This value is 1.33 and this value is 1.2. So this is bigger than this. So alpha will be bigger than theta. So resultant velocity will be like this, somewhere here. Understood? So this complete angle will be alpha. Now, B will be at rest. Now, B will be at rest and A will move on this line. So this will be the minimum separation, R. This will be the minimum separation. Understood? समझ में आ रही सबको? And now we have to find this minimum separation and time. That we'll do. See how? This is the resultant velocity, 25 meter per second. Okay. Now, you can see that time travel to come from A to point C. This is the this much time will be taken for the minimum separation. See, see in this triangle, if you see AO and suppose D, this length is 400 meter is given. This angle is alpha. So you can find this distance. How? If you apply tan alpha, that is this distance upon 400 into tan alpha equal to tan alpha. So this distance will be 400 into tan alpha. So 400 into tan alpha. So 400 into 4 by 3. So this is 1600 by 3. This is going to be 533.33, right? So this you can find. Now, what is the use of this? You can find, no problem. So this you can find. Total 533. Suppose approximately I am taking 533. So 533 minus 500. This is 33. And if this angle is alpha, this is 90. So this is going to be 90 minus alpha. This is 90. So this is going to be alpha. Now, you have to find minimum separation. We'll simply apply cos alpha. So cos alpha is base upon hypotenuse. That is 33. And tan alpha you have 4 by 3. So alpha 4 by 3. So this is 5. Tan alpha is 4 by 3. So cos alpha will be 3 by 5. So this is 3 by 5. So minimum separation will be 99 by, or you can say if you take 33 as well, this one. So it will be approximately this into this 100 upon 5. That is 20 meter. So minimum separation should be 20 meter. All right. So minimum separation will be 20 meter. Now, note it down. First, you note it down till here.
I got the answer.
You got the answer. Very good. Noted, everyone. Now, I'll find time. So minimum time. So time taken from to come from A to C. So this distance AC we need because we have velocity. We need AC. Achha. How will you find this? How will you find this AC?
So isn't it just a resultant of 400 and 500?
500 is this much only till here only.
Okay, then
Yeah.
3.3.
See, one thing you can say that resultant of 400 and 533. This complete 533 and 400. So you can find this complete length from here to A to D. And now in that A to D, you have this distance 33.33. You apply this sine alpha, you will get this distance, and then subtract from this whole this thing, you will get this distance. So AC can be written as AD minus CD. AD you can write under root 400 square plus 533.33 whole square. and minus CD. CD is this much. So sin alpha is this upon this. So CD is 33.33 into sin alpha. So you can find time equal to AC upon this 25. That is how you can find. So I'm not going to calculate this thing. अब रो आया तुम्हारा कि नहीं आया?
तो मैंने तो डायरेक्ट 400 और 500 का रिजल्टेंट निकाला 640, उसको 25 से डिवाइड किया, मुझे आ गया 25.6।
क्या किया?
400 और 500, तो मैंने AC निकाला, वो 640 आया और उसको 25 से डिवाइड किया।
तो वो कैसे होगा? 400 और 500 का रिजल्टेंट कैसे आएगा AC?
90 डिग्री है ना, तो वेक्टर एडिशन किया मैं।
अरे भाई एक बात बताओ, ये 500 यहां से लेकर के यहां तक है और AC ये है।
हाँ, पर आंसर आ गया मुझे, मैंने AC निकाला, मैंने AD नहीं निकाला।
लक के लिए आ गया होगा, क्योंकि देखो 500 अगर ये है तो ये तो अलग होगा ना, ये अलग ट्रायंगल का, ये तुम्हारा आ सकता है जो भी 640 वगैरह जो भी लाना हो, ये तुम्हारा 640 आ सकता है, ये AC कैसे आएगा? तुम्हारा आंसर आ गया वो है, अलग बात है।
So when we get AC, what do we do, sir? We don't have time.
You got AC, right? This is the resultant velocity. So distance upon velocity, you will get time.
Oh, we use it. Okay.
Yeah. Now, done everyone? Okay. Next question. Great question. You have a equilateral triangle. You have an equilateral triangle. There are three boys sitting here. A, B, C. Three boys sitting at the vertices of an equilateral triangle, side L. And all of them have velocity V. No, not V. Not velocity, speed. All of them have constant speed. Constant velocity I cannot say because no direction will change, so velocity vector will change. But they have constant speed. A, B, C, all of them are moving with constant speed. And A will always head towards B, B will always head towards C, and C will always head towards A. Matlab, see, B is here, so A is like, moving in this way. Suppose B will, after some time, B will come over here, so A will have some this kind of direction. If B will come over here, A will be like this. Always, A will always point towards B. Similarly, C will always point towards A, and B will always points towards C. Understood? So you have to find where exactly A, B, and C meet. Second, time taken. How much time they will take to meet. Third, displacement of any of A, B और C, किसी एक का. And D, distance traveled by any of them. Just take 2 seconds, then answer. Okay. Any luck, guys? किसी को कुछ समझ में आया?
सर वो BC लेंथ L/2 पे मीट करेंगे क्या?
में से यहाँ पे
हाँ सेंटर पे।
क्वेश्चन ही नहीं समझा। मैंने क्या बोला? A will always be directed towards B. B will always in the direction of C. C will always in the direction of A. See, I'll tell you. See, as this question says that this is equilateral triangle, right? Now, suppose, and I already told you, like, see, when B, suppose in starts, right now, A is, like, A is heading towards B is heading towards C, and C is heading towards A. Now, B will come some distance. Suppose B will come here. B, though, like, B will not come over here because, B will, none of them will travel on the sides of the equilateral because, every, like, all of them will travel. So, see, if C has come some distance, so B will also come, A will also come. So, suppose A come here, then C has to come, C has to, like, travel in the direction of A. Suppose A come here, A come here. Though, like, A will not travel on the side, A come here. So C will travel. Initially, A was here, so C was traveling in this direction. Now A has come here, so C will travel not in this direction. Something like that. So they will not, like, travel on the sides of the equilateral triangle. They will all travel. See, after some time, B will come over here, C will come over here, and A will come over here. Did you understand? Because, when A will move, C will move in the direction, like, C will move, like, in the direction uh, towards A only.
सर
Hmm.
टाइम टेकन 12/v है क्या?
हाँ, आई थिंक एक मिनट चेक करने दो आंसर मुझे।
मुझे सिर्फ टाइम आया।
नहीं, 12/v नहीं है, 12/3v है। So did you understand, like, why they will come like this? So B will come over here, C will come over here, A will come over here. Did you understand that? Why? And now, suppose, now just complete this triangle. And I guess that this triangle will again be equilateral triangle.
सर एक स्पाइरल जैसा फॉर्म होगा।
After some time, they will come over here. And again, this will be the equilateral triangle. Why so? Can anyone tell me why so?
सबका लेंथ वेलोसिटी सबका सेम है, तो ये रेड ट्रायंगल का सारे साइड्स इक्वल होंगे, डिस्टेंस ट्रेवल्ड इज इक्वल।
Huh. All of them have same speed?
So A will go to B's position.
No, not A will come here. A will come over here, B will come over here, and C will come over here. All are traveling for same amount of time, so with same speed. And why I can say that they will again form equilateral triangle because see, if I try to analyze this, so B is initially over here and C is here. So B has this velocity, V, speed, and C has speed V like this. So this is 60 degree. So this velocity will have two components. One perpendicular to line BC, that is C sine 60, and this V cos 60. If you do the same thing over here, AC, again this is 60 and this is V. Again, this will have two components, V sine 60 and V cos 60. You can say that they have velocity of approach v minus v cos 60, that is v by 2. Again, they have same thing. Velocity of approach v minus v by 2. Again, we'll have the same thing here as well. So between B and C, C and A and B, all of them have velocity of approach same v by 2. So they will try to approach each other uniformly. So after some time, they will come over here. Again, they will start. They will come here. B will come here. C will come here. And A will come here. Again, they will make another equilateral triangle. And like that, they will keep on traveling and meet at some point. And the most symmetrical point of this triangle would be centroid. So they will meet at centroid. Understood? They will meet at centroid. Now, so you can simply find this is the centroid A, B, C. This is L. So you can find the distance and all. Suppose so they will meet at centroid. That is G. And displacement would be initially particle was here or here or here, and this is equilateral triangle, and this is centroid. So this will be the displacement. This will be the displacement of A, and this will be the displacement of C, because finally man has come from here to here. So the shortest length between their final points and initial point. So this is the displacement. So you can simply find this is L by 2, and this will be, and this is 30 degree, right? Equilateral. This is equilateral. So we can find this distance S. How? Cos 30 equal to L by 2 upon S. This is root 3 by 2. So displacement is L by root 3. You got this thing. Displacement, that is L by root 3. Guys, all right till here? Everyone?
Yes.
Now, first you note it down, then I'll solve again. Whatever, if you like, if you want to note anything, then you can note it down. देवयानी, मैंने तुमको बोला है, शागिनी को भी बोला है कि 5 बजे आना है तुम लोग को हर एक क्लास में फिजिक्स के। क्यों नहीं आते हो? फोन करना पड़ता है।
सर मैं तो आई थी।
डेली आना है। आ जाओ ना अभी।
ये वीक एग्जाम्स चालू थे इसलिए मैंने अप्लाई किया।
ठीक है, ओके।
नेक्स्ट वीक सर। हेलो।
इस वीक तुम्हारे एग्जाम खत्म हो जाएंगे?
परसों तक।
ठीक है।
एक प्रैक्टिकल सर।
हाँ, ओके। Yes, I see. Centroid is the point of intersection of medians only. Okay, done everyone, right? Now, I want to find time taken. Now you can see that if you take any pair, A, B or B, C or C, B has velocity V and C has velocity like V. But we have broken down this into component. So this is the velocity of approach. Now you can see that initially the separation was L, and finally when they will meet, separation will be 0. Here separation will be less than L and more than 0. So separation keeps on decreasing, right? So separation will keep on decreasing. So what would be the velocity of approach? That is V by. This is the velocity of approach, and rate of separation, dr by dt, that is negative. Rate of separation, let's say at any moment, the distance between them is r. So dr by dt must be negative because separation is decreasing. Now, right? Now you can see that. Oh, my bad. Sorry, it's my bad. It's my bad. B is trying to approach C and C is trying to approach B. So this is called the velocity of approach. That is V plus V by 2. Both are trying to approach each other. And that is how separation is decreasing. So this is minus dr by dt. That is 3V by 2. So this is dr equal to minus 3V by 2 into dt. Just integrate this. So R, what was the initial value of R separation? L. And what will be the final? 0. Time t equal to 0 to t. See, this is like in this line, we do not have anything variable. So we can directly do. But no, I'm using integration just in case like we will have something variable. In that case, integration will help. So integration of dr is r, then 0 to L, and this is minus 3V by 2, and integration of dt is t, 0 to t. You can put this 0 minus L, that is minus L. This is minus 3V by 2 into t. So if finally you can say t is 2L by 3V. Understood?
Yes.
Noted. Now we have to find how much distance that will cover. How much distance that will cover. So distance is like like this object will keep on going, and will come here. So this is the triangle. Suppose this will be kind of a curved path. So you have to find total distance. So how do you find total distance? You know that boys are traveling with constant speed. So velocity, and you have total time 12 by 3b. So total distance traveled is 12 by 3. Total distance traveled is 2L by 3. I hope you guys have understood this concept.
सर मैंने टाइम अलग मेथड से निकाला, मुझे आ गया 12/3V।
कैसे?
वो तो अभी मैं ओरली बोलूँ तो होगा नहीं वैसे, मुझे
क्यों?
लिख
अच्छा, कैसे आ गया भाई? फिर बोल दो ना, तुम कॉन्सेप्ट क्या लगाए हो, समझ जाऊंगा।
मुझे बनाना पड़ेगा, इसका डायग्राम बना के ही होगा।
छोड़ो, रहने दो, फिर रहने दो। सबका नोट कर लिया?
मैं आपको डायग्राम भेजता हूँ बाद में।
अच्छा, इस चैप्टर का लास्ट क्वेश्चन ऑफ दिस चैप्टर, आफ्टर दिस चैप्टर विल बी फिनिश्ड।
सर मैंने आपको भेजा, मैंने जो बनाया।
Also, add one more question here. Also, find the initial acceleration of point B. Okay, guys. Any luck?
सर मुझे मालूम है इसका डायग्राम कैसे बनेगा, पर सॉल्व करना इसमें इंटीग्रेशन लगेगा आई गेस।
ठीक है, देखो, I'll solve. See, question says that point A moves uniformly with velocity v, so that vector v is continuously aimed at point B. Okay. Point A moves uniformly with velocity v, so that the vector v is continuously aimed at point B, which in turn moves rectilinearly and uniformly with velocity. Oh, okay. See, and at the initial moment of time, v is perpendicular to u. See, this is the case. Here is the point A, and here is the point B. B is going with uniform velocity and speed, uniform velocity u, rectilinearly on this straight line. And A has initial velocity, initial speed v, and always directed to always aimed at B. When B will come here, so A will have velocity vector in the direction of this. When B will come over here, A will have direction in this direction, velocity in this direction. So A will be moving like this. A will be moving like this, right? That I'll come later. First, let me solve this. Let me find initial acceleration. So, see, so this is the condition at time t equal to 0. We have to find the initial acceleration. Initial acceleration means instant acceleration at time t equal to 0. We know that acceleration is dv by dt. Delta v is v final minus v initial upon dt, suppose in a very small time, if I consider. Suppose after very small time, dt time, b will come some distance. I'm just making the picture bigger so that to have to just to to have clear picture. But discussing about the very small amount of time in dt. So this distance will be u into dt. And now because b has come over here, so a will have this direction. In this direction, a will be aiming. So in dt time, this angle this will form very small angle d theta. And initially, this is the initial velocity of a, and final speed velocity. Final velocity will be different, but a has uh, a is traveling with constant speed. So direction will be different, but speed will remain same. So again, this will be the final speed. So now, how do you find the resultant vector of this? V final, if you some magnitude, or how do you find magnitude or magnitude of addition of two vectors or subtraction of two vectors? Vf square plus Vi square minus 2Vf into Vi into cos theta upon this dt. We know that speed is same. So Vf is also V, Vi is also V. So under root V square plus V square minus 2V square cos d theta, not theta, d theta. It should be d theta, very small angle between them, upon dt. So V square plus V square, 2V square, 2V square. You can take common. So under root 2V square, 1 minus cos d theta upon dt. Now, under root 2V square. This is like 1 minus cos theta. 1 minus cos theta is 2 sin square theta by 2 upon dt. So from here you can say 2V square into 2, 4. 4 so it will come out square root 2V sin d theta by 2 upon dt. Now we know that sin theta is approximately equal to theta if theta is very small. And this is d theta, this is a very small angle. So we can simply write 2b into d theta by 2 upon dt. So 2 and 2 gone. So this is v d theta upon d. Now you can say that we know that in the circle, we know this theta equal to L by R. So L is how much? U into dt. L is U into dt and R is L. Because this is in the beginning only. So this separation was L. Separation is L, right? So this is very small. Na? So this is very small. So this will be considered as arc length. So radius of that would be L only. So put here. So V d theta. So angle is d theta. That is U dt upon L, and here dt. dt gone. So U into V upon L. This is the initial acceleration of that. Understood? Note it down.
So can you explain again what you did for the last step?
Well,
So I didn't understand the last step. Please.
This one.
Yeah, that part.
See now, in a circle, suppose this is radius, this is angle theta, this is L. So theta equal to L by R, we know that.
Yes, sir.
So this is very small angle. So this is like, this is also L, this is also L, this is d theta, and this is like arc length, that is equal to U dt. So theta equal to L and upon R. R is the radius then. Understood or not?
So, but how do we connect it to the previous equation? Do we just substitute?
I just substituted this d theta here in this equation here.
Oh,
V
okay.
d theta by dt and just cancel dt dt. Done? Understood, China?
Yes, I understood.
Note it down. Done till here?
Yes, sir.
Everyone? Okay. Now, second part now I'll solve. See, second part is little tough. A was initially here, length was this was, B was here with some uniform velocity and this has uniform speed. Now see, A will always aim towards B. So A will follow this path. And somewhere B and A will meet here because of the U is less than V. So definitely B will be caught by A somewhere here. So it is asking how soon, which time you have to find. After that, they will converge, they will meet. Okay. See, initial separation between A and B was there. So at some point, suppose B has come over here. B has come over here. So A will also come somewhere here, and A will head towards B because B is here. So A will aim towards B. When B will come over here, A will aim towards B again. Like this, A will keep on traveling. So now you can see that. So at this moment, at any time t, if you see, this is the separation between A and B, and separation keeps on decreasing. Finally, it will become 0 when they will meet. So suppose at any moment, separation is S. So separation is decreasing. Means we have to define the velocity of approach. They are approaching towards each other. So at any moment, suppose the speed of A will remain constant, that is V. Speed remains constant, right? And suppose this is the angle at some time, this this speed will make some angle with the horizontal theta. Let's say this is theta. And B is here. So B has velocity u. If you extend this line, this angle will also be theta. So break this into two components, u cos theta and then u sin theta. This has no significance over here. But now we can see that A is trying to approach B with velocity v, and B is trying to go away with velocity u cos theta. So what would be the velocity of approach? V minus u cos theta. Isn't it? Tell me. Understood or not? All are gone. Only Parth is visual.
Yes, understood.
All Parth is in a visual region, like all are in infrared, ultraviolet region. Cannot see. Okay, fine. Hope all are good. So this is the velocity of approach, right? A is trying to approach. Now I'll define it minus ds by dt, because we know that separation is decreasing, so rate will be negative. Rate will be negative. V minus u cos theta. Now I'll simply integrate. So ds will be, just reverse this, u cos theta minus v into dt. Integrate this. In time t equal to 0, at time t equal to 0, initial separation was L. At time equal to t, separation is something 0, because finally they have to meet. Na? So suppose time t, after t time they will meet. So separation will become 0. So this is minus L, and this is 0 to t u cos theta dt minus 0 to t v dt. Now you can see, just you can consume this minus L. This will be like v is constant, speed is constant. So integration of dt, that is t, put the limit. So it will be t. This is u is constant, will come up 0 to t cos theta dt. Now you cannot integrate this because theta is different variable, time is different variable. You cannot integrate this. Then how would you do this? Now we have to apply, think about some other thing. See, after t time, A and B will meet. So in that t time, B will travel this much distance, that is ut. And if you see, A will also have same horizontal displacement. So suppose if you consider this x and this as y, then B will have displacement along x-axis, that is ut, and A is also finally coming from y-axis to x-axis. So A will also have displacement along x-axis, same to ut, but A has a different velocity. So you cannot directly find the displacement of A. So you have to find the displacement of A in very small time dt. So if you see over here, if you break this into component, that is v cos theta and this is v sin theta. So at any time t, A has this velocity along x-axis, and velocity along x-axis will give displacement along x-axis. So if I consider the displacement in very small time dt, then this would be the displacement in very small time dt for A, and you just have to integrate this. Means you add infinite small time displacement in dt, displacement in dt, displacement in dt, displacement in dt time, displacement in dt, and if you add it, you will get finally displacement in total journey. So just integrate this. This is displacement of A along x-axis. V will come up, or integration of cos theta dt time t 0 equal to t. And this is equal to how much? Ut, displacement of B. So integration 0 to t cos theta dt equal to ut upon V. So for this now, we'll put this value. That is how we can eliminate this term. So L equal to Vt minus U into Ut upon V. So this is L equal to V square minus U square upon V into T. So T we can get LV upon V square minus U square. Guys, understood or not?
Yes, sir.
So how did you equal UT equals V?
See, in T time, like in projectile, you have already studied projectile. So in T time, B is going from here to here. So B will travel like B has constant velocity. So in T time, it will cover UT distance. And A is coming from here to here. So displacement along Y will be L for A, and displacement along X will be this much distance. And that is equal to B, because A and B are meeting each other.
Okay, got
They
it.
will meet each other.
Yeah.
And this is all about this chapter. Now in from next class we'll start, means from next week we'll start Newton's law of motion. This Sunday we are going to have test on this chapter, kinematics, only physics. तुम लोग का वीडियो वगैरह कहाँ गया भाई? तुम लोग एकदम शांत हो गए बिल्कुल. रश्मि, शागनी का साइनी का लैपटॉप चार्ज हो रहा होगा. श्रेया, समझ में आया? अर्चित, जिंदा हो?
Yes, sir.
प्रणय, तू जिंदा है? हाँ. इसमें भी तो किया ही होगा ना ऐसा क्वेश्चन? ऐसे पूछ रहा हूँ खाली, बताओ ना रश्मि. क्या बोल रही हो?
नहीं किया.
अच्छा, क्लास में भी नहीं करवाया गया?
नहीं सर, क्लास में नहीं सर. मतलब ये जब भी पढ़ा रहे थे तभी ऐसा कोई सम था ही नहीं जिसमें इंटीग्रेशन आया था.
इसलिए कहता हूँ ना, अगर पॉसिबल हो तो 5 बजे आ जाया करो. इट विल बी अ गुड रिवीजन फॉर यू गाइस, 12th वालों के लिए. ये तुम लोग बस टाइम कम है अभी. जितना ज्यादा टाइम दोगे उतना बढ़िया रहेगा. आई एम डायरेक्टली टेकिंग क्वेश्चन फ्रॉम एरोडो. एरोडो तुम्हारे यहाँ कहाँ लेते हैं पेस वाले? ओके.